Hello, this is Xtal. In this tutorial, we're going to build a horizontal drift effect using a feedback-based system in TouchDesigner. This effect gradually expands the image horizontally over time, creating a surface that feels both digital and organic. We'll start by building a slit-based masking structure, and then introduce a feedback loop to drive the horizontal expansion. After that, we'll enhance the motion by adding displacement, color manipulation, and edge overlays to bring more depth and texture into the system. As you follow along, focus on how a single system can expand into multiple variations of color and texture over time. Today's goal is to create a simple but visually striking experimental visual system. Now, let's break down the network and build it step by step. First, create a movie file in Top and load your video source. Since this effect is driven by a feedback system that continuously expands over time, it's better to use footage that contains some texture or detail. A completely static image can work, but subtle motion or surface variation will make the drift more visible and interesting. Resolution isn't critical, but very low resolution footage may lose detail as the feedback accumulates. Now that we have our source, we'll start building the structure that drives the horizontal expansion. Next, add a fit top to standardize the output resolution. In a feedback-based system, changing resolution in the middle of the network can break the accumulation structure, so it's important to define a base resolution from the beginning. Here, we create a constant top and set it to 1920 by 1080, then reference those values inside the fit top's resolution parameters. This way, if we ever need to change the resolution later, we only need to modify the constant top, and the entire network updates automatically. It may seem like a small setup step, but when building systems, this kind of structure is very important. After the fit top, add a null top to organize the base source. The null acts as a simple pass-through, but it creates a clean reference point in the network, making it easier to modify or expand the system later. Next, add a multiply top. Multiply performs a pixel-wise multiplication between two inputs. Since the second input is not connected yet, you'll see a warning icon. Soon, we'll connect a slit-based mask into this multiply node to begin shaping the image horizontally. This may look simple, but it forms the foundation of the horizontal drift system. Match the resolution of the rectangle to the base resolution we defined earlier. In a feedback system, mismatched resolutions can break the accumulation structure. Especially with nodes like multiply, different resolutions may trigger automatic resampling, so it's best to keep them consistent. Adjust the size parameter of the rectangle to create a thin horizontal slit. Reduce the vertical scale while keeping the horizontal scale full width. This white area defines where the image will pass through. The thinner the slit, the more defined the horizontal drift will appear once the feedback starts expanding. Add a transform top after the rectangle to adjust the slit's position. Use the translate parameter to move the slit to the center or any desired location. This may seem like a simple positioning step, but it determines where the horizontal expansion will originate once the feedback starts. Now connect the transform output to the second input of the multiply node. Since multiply performs a pixel-wise multiplication, only the white area of the mask allows the image to pass through, while the black areas remove it. As a result, only a thin horizontal band of the image remains visible. This slit becomes the starting point of the horizontal drift effect. Here, I slightly increase the scale in the multiply node to enlarge the image. This makes the content inside the slit start in a slightly zoomed-in state. Once the feedback loop is introduced, this enlarged information continues to accumulate over time. Even a small scale adjustment at this stage can influence the overall density and character of the horizontal drift. Small changes early in the system often have a strong impact later. Now, let's connect the output of multiply into a feedback top. Feedback brings the previous frame's result into the current frame, allowing the image to accumulate over time. At this stage, you won't see much change yet because the loop isn't complete, but this node is the core of the horizontal drift system. Feedback isn't just repetition, it creates a temporal layering structure. Next, add a composite top to combine the current slit image with the previous frame coming from the feedback. Now assign the composite output as the target top inside the feedback node. This connects the current frame's result back into the next frame, completing the feedback loop. From this point on, the slit image begins to accumulate over time. The image is no longer a single frame. After the feedback, add a blur top inside the loop. In a feedback system, frames continuously accumulate, which can make edges appear harsh or overly sharp. By introducing a subtle blur, the layers blend more smoothly over time, creating a softer surface flow. After the blur, add a transform inside the feedback loop. Apply a very small translate value on the x-axis. This subtle horizontal shift accumulates frame by frame, pushing the image sideways over time. The key is to keep the value extremely small. In a feedback system, even a tiny movement becomes significant as it layers over time. This is the moment where the horizontal drift truly begins. The image is no longer static. It becomes a surface that flows sideways through time. Now let's combine the feedback-based horizontal drift with the original footage. Add a composite top and connect both the drift result and the original movie file in. Set the operation to over. This allows the expanded slit layer to blend with the original image, making the drift feel more integrated and natural. Instead of appearing as a separate effect, it interacts with the base image. Now add an edge top to extract the structural boundaries created by the drift. The edge node detects luminance changes and generates contour lines. Since horizontal drift layers frames over time, subtle structural patterns begin to form along the boundaries. Applying edge makes these hidden structures more visible. Once composited back into the image, this layer adds tension and a more digital texture to the drift. This step isn't mandatory, but it significantly increases the visual density of the effect. Next, add a crop top to clean up the edges of the frame. As the feedback and transform accumulate over time, empty areas or unwanted expansion can appear near the borders. Using crop allows us to remove those unstable edges and keep the composition controlled. Especially in a directional system like horizontal drift, final frame cleanup is important. Add a final transform to fine-tune the overall framing. This allows you to slightly adjust scale or position to refine the composition. Next, add an out top to clearly define the final output of the network. The out node helps organize the pipeline and marks the final result. Finally, connect a movie file out to render the completed horizontal drift effect. With this, the full system pipeline is complete. Now let's create an alternative color version using the same system. By changing the composite operation or introducing luminance-based differences, we can generate a completely different mood from the same structure. In the horizontal drift system, the movement remains the same, but color and contrast dramatically change the overall impression. The key here isn't rebuilding the network, but deriving variations directly from the existing system. This approach allows us to expand multiple visual versions from a single structure. The third expansion focuses on altering texture and color rather than changing the movement itself. Here, we use a displace node to introduce subtle surface distortion. While the horizontal drift defines the temporal sideways motion, displace adds organic variation to the surface. It's important to keep the displacement values subtle. Small distortions accumulate over time within the feedback system, creating increasingly complex textures. At this stage, we can also adjust color treatments to generate a completely different mood from the same structure. Here, we use a reorder node to remap the RGB channels. Instead of keeping the original color structure, we swap or reinterpret channels to create a completely different mood within the same motion system. The movement remains identical, but the color identity shifts dramatically depending on how the channels are reassigned. This allows us to redesign the atmosphere without modifying the core feedback structure. One system, multiple color variations. After reordering the channels, HSV adjust is used to refine the color identity. Shifting hue slightly can completely change the temperature of the image. Increasing saturation emphasizes the accumulated feedback structure, while adjusting value affects contrast and perceived depth. This stage does not alter the motion system. It redesigns the mood of the system. The same movement and distortion can feel cold, neon, or minimal depending on the color configuration. One structure, multiple visual identities. Here, we use crop to isolate a specific region of the image. As feedback accumulates, some areas can become visually noisy or overly stretched. Cropping allows us to refine the composition and increase visual density. The motion remains intact, but we become more intentional about what portion of the frame is revealed. Today, we built a feedback-based horizontal drift system. We defined the motion structure, introduced distortion, reordered channels, refined color identity, and clarified the composition. Finally, we branched the system into multiple outputs, exporting each variation as an independent result. The core idea of this tutorial is not about creating a single effect, it's about designing a system. The movement remains constant, but texture, color, and composition shift, allowing one structure to generate multiple visual identities. One system, multiple outcomes. This structure is not limited to horizontal drift. Any system that uses feedback can be expanded in a similar way. The key is not making extreme adjustments, but understanding the structure and knowing where to intervene. Small changes accumulate over time, leading to dramatically different outcomes. Now try applying this system to different source material, different aspect ratios, or entirely new color identities. Creating your own variation is the final step of this tutorial. Thank you for following along until the end. I hope this tutorial was not just about building an effect, but about understanding how to think in systems. I'd love to see how you expand this structure into your own experiments. If you found this helpful, consider subscribing and supporting the channel. I'll see you in the next video with another visual system. Thank you.